I believe in faith. Religion can give me all the answers. In fact, I don't talk about what I know. I talk about what scientists don't know. And in fact, how they do their work. Let me give you an example. Einstein one time was asked, how did he come up with his theory of relativity? And he said, it's like this story. There was a scientist walking out in the countryside. He became lost. He shouted out, I'm lost. Can someone help me? Where am I? And a farmer nearby shouted back, said, you're standing on a road next to a pasture. The scientist said, road? I understand, but what is a pasture? Pasture is a place where cows graze. Graze, I understand, but what is a cow? The farmer said, a cow is an animal that gives milk. Animal, I understand, but what is milk? The farmer said, milk is a white liquid. Liquid, I understand, but what is white? White is the color of a swan. Scientist, color, I understand, but what is a swan? Farmer said a swan is a bird with a long neck. Neck, I understand, but what is long? Farmer shouted back, long is not short. Scientist thought for a minute. He said, now I know where I am, and continued on his way. I believe in facts. Science can give lots of answers. In fact, science today is based on a founded process where no one takes things in faith, but there is a process of discovery. And in fact, those discoveries are built on top of each other. And in fact, there's encourage others to test those discoveries and not just take things from one person's opinion. How do we challenge our fact and faith thinking, and how has the religion dealt with science? Take up the situation of Galileo. He was imprisoned by the church for many years up to the end of his life because he believed in his observations. And his observations showed that the earth was not the center of our planetary system, but in fact the sun was. Now, of course, the church now, 400 years later, has just recently admitted that it had made a mistake. Well, let's talk about what does science know today. Science does know a lot of things, and the best way to understand what science knows is to work through by dimensions of what we do know from things. The first place to start is quarks. These are the smallest materials, particles known to man, and in fact there's a large experiment being built in Europe presently to go and start to study these fundamental particles even to more detail. The next field up, and we're going to go in steps of 1,000. So if everything gets 1,000 times larger, if you can imagine 1,000 times larger, we're going to go through these different fields of science, and each one kind of has a particle or has a theme inside of it that you can relate to make measurements with. This is nuclear physics. Nuclear physics, the main theory and exploration is something called a proton. The next an order of magnitude up, 1,000 times larger is the atom. This is the study of atomic physics. There's many theories and capabilities on this as well. The next factor of 1,000 larger is chemistry. And maybe one of the best evidences of chemistry is the molecule. Here is a DNA molecule. The next factor of 1,000 larger is biology. Here's a study of something like bacteria. And again, you can think of these fields, there's lots of theories and understandings and science behind each one of these scientific fields. The next one up is mechanical tolerances or material science. Here is shown an eye of a needle and a thread going through it. And again, lots of theories and explanations of this over the years have been developed. Another factor of 1,000 up is basically sociology, the study of humans. And here's again something about 1 meter in diameter and fits into our human scale, human size types of events. What's interesting about the study of our science is the human scale is almost at the dead center of it. We're about 12 orders of magnitude smaller we study, and 12 orders of magnitude larger we can study. But it's interesting that our human scale is at the center of these studies. Another factor of 1,000 up is a farm. something about the size of a farm is 1,000 times larger than a human being. And this is a study of like surveying, the science of surveying. Another factor of 1,000 up is the study of geology, the study of continents. Another factor of 1,000, we're in planetary science, the size of planets. Another factor of 1,000 up, we're in astronomy, the field of astronomy, and the study of solar systems, planetary systems. Another factor of 1,000, we're in solar physics. And this is an explosion of a star that has gone through its life cycle, and it forms what are called nebulae. Another factor of 1,000 up, we're at star clusters. Clusters of stars and with planetary systems, but clustered together in a very unique patterns. Another factor of 1,000 up, we're at galactic science, the size of a galaxy. Here's a galaxy. It contains over 100 billion stars in a typical galaxy. Another factor of 100,000 up is superclusters. These are clusters of galaxies, clustered together here, as you can see, holding them together. And now another factor of 1,000 larger is we're at quasars. Quasars are objects that are believed to be at the very edge of our universe, the farthest distance from us, and is the study of cosmology. So in fact, this talk is quite interesting because it combines the concepts of cosmology all the way down to quantum physics and God. So what things don't we know about quantum physics? Let's move back down to our scale of sciences here and get down to quantum physics. What things are still taken on faith? And in fact, it's quite interesting. Many fundamental physicists that study particle physics go and talk about God and the role of God, because they use God as an example of bringing some explanation to something that they're about ready to discover, or some place where they have not discovered things yet. You know, one of the most bizarre things about quantum physics is how many fundamental particles there are. There's quarks. There's given them strange names: up, down, top, bottom, charm, strange. 6 different types of quarks. Each of these have antiparticles as well associated with them. Then there's leptons. There's 6 types of leptons as well. And then there's these force-carrying particles, like the graviton, the gluon, and the photon. And the latest one we're trying to discover is the Higgs boson. This is what the big experiment is being built in Switzerland for, is in the Switzerland-French border, to go and build enough energy to describe and find the Higgs boson. Those particle accelerators that they build are fascinating machines. It's like people describe it as 2 ping pong balls circulating each in counterclockwise methods, opposing each other, and coming at the speed of light and hitting each other. And from those 2 ping pong balls, you get a bowling ball for a femtosecond, small amount of time, and then that disintegrates into many other types of particles. But this is the concept of how these experiments are done. And it's quite bizarre, and many things are taken on faith of how these particles work and how they get discovered. So, what don't we know about cosmology? Let's take us again through all the sciences, as what we do understand quite well, and get to the other edge of our understanding, which is again the largest objects. The whole universe is one object, and it's studied in great degree, and represented here by the object that's farthest away, which is the core. What are some of the things that we take on faith, that we have difficulty, or some of the bizarre facts of cosmology? First of all, is that only 5%, less than 5% of the universe is material that we can see. Things like us, in this screen, and pictures and so on, things you can hold. Only 5%. 95% of the universe, we can't see it. In fact, we can't even detect it and try to deal with it. There's a theory that it's either dark matter or dark energy. And so there's thoughts going on. In fact, the studies of the quantum physics, the properties of those small particles, how much mass they have, what their properties are, will help us explain where this missing matter is, or this missing energy is from our universe today. Another interesting fact is the Big Bang is still accelerating, so it's still banging. This is quite an interesting problem, I think, for scientists today is to explain why is the Big Bang still banging. We think of a bang, it's over, and then there should be a slowdown. But our universe continues to accelerate. One last interesting aspect of science today is a very interesting parameter that's been studied for the last 100 years. It was first proposed by Einstein, and it's called lambda. It's a term in his gravitational equation that talks about if there's some force that causes the universe to be stable. And in fact, this term lambda is first coming in and out of this equation over and over again. At first, he described it as making his largest blunder because redshift was first being studied and it's shown the universe to be expanding. And he put lambda in to make the universe be a stationary universe, much like religion would like to see things to be stationary. But the fact that with or without lambda, the universe is expanding, this means very clearly there's a beginning, a middle, and an end. And in fact, this cosmological constant is called lambda, plays a very important role throughout the last 100 years. And it's in fact a signature, I believe, to science and the boundary between science and religion. Because religion wants things to be stable, science is just observing things and saying they're not stable. And so this term comes in and around the study and kind of is the conflict. And as long as lambda is there, it really does show this transition between science and religion and how you do this. And in fact, lambda is a very difficult thing to measure precisely. So many times it's taken on faith what that parameter should be. So, where are we? We've had a short journey in understanding science and the different disciplines of science and how there's different facts. And many of those facts, as you go through those fields, you can start to understand some of those facts yourself. You recognize things that are there and you take them for fact. What's also interesting is the study of our smallest particles, quantum physics, the study of our largest, the cosmology of the universe. They have many mysteries still associated with them, and there's many things still taken on faith. In fact, those scientists work to understand that, and in fact, they use things like the God particle and observers to try to explain these concepts and bring them forward and bring thoughts forward so that they can bring them into some facts and establish those facts. So, what's also interesting about those fields of quantum physics and cosmology is the greatest minds on the planet are attracted to study those fields. And they work very hard on these fields to explore it and understand these things. The problems are so complex. And they get very, almost have a religious approach to them sometimes. So I think religion and science is very well connected. They're always connected every day. And finally, maybe we should leave with the concept of lambda. Lambda as a term. Lambda as a motive, lambda as a theme that can take us forward and help us build together. Because it's a little bit of a hunch, it's a little bit that lambda's taken on faith, there's also a little bit of fact behind it, it's come into equations, out of equations, into equations for the last 100 years. It really is an example of this challenge or this boundary between science and religion and how you're trying to mate up observations with facts, and these terms come into equations to fit that together. So as I say, lambda is for just enough lambda for us. In fact, there's some lambda for every religion. You should start to understand and look at some concept of lambda. So I challenge you to figure out where does lambda fit into